In the previous video, we show you how to use Laravel as a subscriber to an MQTT topic. We send data from an ESP to Laravel through a broker and display it in the browser using a Livewire component. To receive the messages sent by the ESP, we use wire pool in Livewire. Pooling in Livewire is used to automatically update a component at regular intervals without the need for explicit user interaction. It is simple to implement in Livewire, and if your application doesn't have special requirements, I highly recommend this method because of its simplicity. However, a more efficient alternative to pooling, especially in the context of web application, is using WebSocket technologies. These technologies allow the server to send updates to the client without the need for the client to make a repeated request. In this video, I will show you how to implement Laravel Reverb to live update the messages sent by the broker without manually refreshing the page or using Livewire pooling. For this example, I will create a new project to show you all the steps. I use Laravel Heart, so I can type Laravel new ESP Reverb. I open the project in the PHP Storm, and now the first step, I will install the Reverb. For this, I have to write PHP artisan install broadcasting. After the install, I go to the env file and I see by the broadcast connection Reverb, and I have here some app ID, key, secret, and so on, and I will replace the localhost with the name from the application. Next step, I will install the MQTT client for the Laravel, composer, require PHP MQTT Laravel client. Just like in the previous lesson, I have inserted the same authentication details for the broker, and don't forget to place the certificate in a folder in your application. It's important to use a path like this, absolute path. Now the application is ready. I will create a user, and just like in the previous lesson, I will insert here a Livewire component. I have the Livewire component MQTT subscriber. Is empty now, but first I will create the job 2. For example, PHP artisan make job MQTT subscriber job. I have these jobs folder MQTT subscriber job, and here I have to define the connection to the broker in the handle function. Now I will subscribe to the topic, MQTT, subscribe, and the topic in the ESP is command serial message, and I will insert here the topic and function. We have a string topic, a string message, and for now I will log the message. It's the same like in the previous video, but this time I will not insert in the database some messages. I will use log. Now I will go back in the Livewire component, and I will insert the dispatch for this job in the mount, public function mount, and MQTT subscriber job dispatch. Now I go in the dashboard. Here I will delete this stuff, and I will insert the Livewire component in the dashboard, MQTT example, MQTT subscriber. Perfect. I will start the job. PHP artisan queue work, and when I go to the dashboard I see that the job is running. Now when I will write some code, some message in the serial monitor in Arduino IDE. This is a test, and now we can check in the log file, in the storage logs, Laravel log, and I think it's here, or I can search. This is a test. Perfect. Now for the next step I will create an event. For this I have to type PHP artisan make event message receive, for example. And the event I find here in the events folder, and here I have to insert the property message, public message, in the construct string message, and this message I have to insert the showed broadcast, implement showed broadcast, and here I return a channel, no private channel. I will insert a name, for example, MQTT messages. Now I can go back in the subscriber job, MQTT subscriber job. Now in this code we have an issue related to the use of the loop through method in the context of a Laravel job. Loop through enters an infinite loop which blocks the execution of the job. In Laravel, jobs are designed to run once and complete, allowing the worker to process the next job in the queue. However, this infinite loop prevents the job from finish, which means the job never ends and blocks other jobs in the queue. Now I change the code like this. I have the MQTT connection, I subscribe to the topic, I log the message and the topic in the log file, and then I try to broadcasting the event. I use the helper broadcast, new message received, that is the event, and the broadcast function is used to send this event to any clients listening on a WebSocket channel, and if the broadcast fails, the error is logged. And I use now this MQTT interrupt. After processing the received message, the loop that listens for MQTT message is interrupted, and this measure ensures that the job does not continue running indefinitely after receiving a message, which is important for allowing the job to complete and the worker to handle other tasks. And then I start the MQTT loop. The loop is started to listen for incoming message. The true parameter typical indicates that the loop should continue running until it is explicit interrupt or an errors come. Then I have this MQTT disconnect, and after the loop is interrupted and all messages are processed, the MQTT client disconnects from the broker. This is crucial for cleaning up resources and ensuring that the connection is properly closed. And at the end I have exception handling, and that's all the code. I have here optional MQTT client quality of service. This is a level of guarantee that MQTT provides regarding the delivery of a message, and we have a free level of quality of service, 0 at most once, 1 at least once, and 2 exactly once. And now we go to the next step. Now, because I use here in the event this channel MQTT message, I have to define this message, this channel. Here in the channels, you find this file in the routes folder, and here a simple explanation. Here we create a channel named MQTT messages that the application can use to broadcast events. This empty function inside the channel definition is where you can define authorization logic to control who can listen to the channel. In this case it's empty, meaning anyone can listen to the channel. Now I go to the MQTT subscriber livewire component, and now I go to the view, and here I will write some JavaScript code to listen the channel. I will use here in this case Alpine.js. I make a div with x in it, and here I can write JavaScript code, and I will use echo. Echo is installed with Laravel Reverb. Echo.channel, and the channel is MQTT messages, and now we can listen. I will type here the event message, how we say, event message receive, and I need the event, and now we can make a console log here, for example console log, and message receive, and I will insert here the event, and that's all. Now don't forget to run npm build or npm run dev, and I will start the queue, the job PHP artisan queue work, and we start the Laravel reverb 2. We need to type PHP artisan reverb start or reverb start minus debug, and I will start, and it works. I see some publish, subscribe, data, authentication, channel, MQTT message, and now I go to the browser. I insert the component in the dashboard here. Okay, and we can go to the console, and now I will go here in the Arduino IDE, and I will type Laravel is the best, and we get the message Laravel is the best, and it works very fine. Now we can make the message in the view. I will copy this and I will comment this, and we make with Alpine. I insert here X data and message. Now we can make a test with the view, and I go to the Arduino IDE, I write Livewire and Laravel, and I get here the text in the console 2, and it works very fine. Okay, that's all for this video. In the next video we will improve our code. For example, we don't use here the MQTT subscriber job dispatch here, because for if the page is loaded, this will dispatch. But in the next video I will use a different method. Bye.